So yesterday, we drew pictures like this. We talked about y equals sine of theta. We said it starts somewhere here and comes up, down, back up, and we said it goes on and on forever. Right. In both directions. We called this axis theta. And then on so on Friday, we did this for y equals cosine of theta. Called this theta, right? And we said, well, cosine starts up here at 1. We came down, up, down, up, and then we came down, up, down, right? We said this goes on in both directions. And if we notice, what is true about both of these functions is the following. They go up, down, up, up, down, up, up, down, up. And they just repeat the same pattern over and over again. The graphs never go higher than, what was the maximum value? 1. Never go above 1, and certainly they never go below negative 1. Right? Certainly they never go above 1 and never go below negative 1.
Because you wanted to see it.
Right, so why don't you just go over there with them right now? And then when they're doing the quiz, I can come help you.
Okay.
And then we know that these functions just repeat the same cycle over and over and over again. They repeat the up, down, up, down, up, down, never going higher than 1, never going lower than negative 1. We call functions that do this periodic functions. Brandon, we may need to move the screen over to Giselle's desk. Giselle, can you set it up, please? It's still on already. So periodic functions, let's note this down. Periodic functions are functions that repeat a cycle over and over again. They repeat a cycle over and over again. If you want to use a different word for cycle, you could also call it a revolution. Cycle, revolution, same thing. And if you think about the sine and cosine graphs, they just repeat over and over again. Up, down, up, down, up, over and over and over again. They just repeat the same cycle over and over and over again. Now, within periodic functions, there are 3 important terms we need to know. They're abbreviated with the acronym MAP. And the M stands for midline, the A for amplitude, and the P for period. This alarm might go off, Giselle, so you may need to snooze. You can give it to me if it goes off. Midline, amplitude, and period. These are the 3 things we have to remember about periodic functions. So what do these all mean? Let me start with the period. Period is the, and I'll say it in words, then I'll write it, the time it takes to complete one revolution or one cycle. This is the time it takes to complete one cycle / revolution. The time it takes to complete one cycle or revolution. If we think about the sine graph, let me just redraw it here, a quick sketch. The sine graph starts at 0, up, down, up, down, up, down, up, down, up. If we think about the sine graph, if we start right here at the origin, one cycle is from here to, well, it goes up, then it comes back down, then it goes farther down, and then it comes back up. Here is a cycle. From, call it point A to point B. That is a cycle. How do I know this is the end of a cycle? Because that is when the graph begins repeating the, let me go up. We got back to the where we started after completing one whole revolution. And now we're going to do it all over again. And we're going to get back to here, and then we're going to do it all over again. Mariah.
So a revolution is just like that?
So a revolution is,
Yeah, so like 2 months.
yeah. And how did I know that? Because I started at 0 degrees or 0 radians. The coordinates of this point, as you all recall from yesterday, pi over 2 comma 1. The coordinates of this point, pi comma 0. The coordinates of this point, 3 pi over 2 comma negative 1. And the coordinates of this point, 2 pi comma 0. One revolution is going around the unit circle once. The next cycle would be from here, we go up, down, and back up. So right here, here's the next cycle. And then we also have some cycles over here. The cycle over here is up to this point. Up to this point. All right? So these are the multiple cycles. And the period is how long is one cycle. Well, I started at 0, and the cycle ended at 2 pi. 2 pi minus 0 is just 2 pi. So the period, I'll write this here, is 2 pi for y equals sine of theta, and I could have done the exact same analysis, I'll spare you right now, of y equals cosine of theta. The period is 2 pi. The period won't always be 2 pi. Imagine if I stretch this graph out or shrink it, the period will change. But in this case, the period is 2 pi. All right. The next piece I want to talk about is the midline. So the midline, just as it sounds, is a line that is in the middle of the graph. I'll be more specific. It is a horizontal line that cuts the graph in half. It is a horizontal line that cuts the graph in half. So if you think about the sine graph, the biggest value is 1, the smallest value is -1, so the line that cuts that in half will be
0.
yeah. And because it's a line, let's be a little more specific, right? Y equals, this will always be y equals something. It's a horizontal line. It has to be y equals something, right? In this case, it happens to be y equals 0. Now, what is the formula? The general formula is the following. Take whatever the maximum is. In this case, it's 1. For cosine, the maximum is also 1. Plus the minimum. In this case, -1. Divided by 2. So you want to find the average of the max and the min. 1 plus -1, 0. 0 divided by 2 is 0. So the midline is y equals 0 for sine of x and cosine of x. Y equals 0. Horizontal line, And on the graph, how do I indicate that? Well, right here. This horizontal line at y equals 0. It will not always be at y equals 0. Imagine if I shift the graph up, but we're going to get to that next week. And the last piece is amplitude, and amplitude is the distance from the midline to the max or the midline to the minimum. The reason we have or is because both of these values are the same. You think about it, the middle to the max has to equal the middle to the bottom. If you think about this, the middle is at 0, the max is at 1, so we would say that the amplitude, which is this distance right here, from the middle to the max, would be equal to 1. You could say it another way. The distance from the middle to the minimum is -1, the middle is 0. How far apart is that? That's 1 unit apart. So the amplitude is here. One thing to remember with amplitude, if you think about it, it's a distance. Distance is always a positive number. So must be positive. Must be positive. And the formula for amplitude is maximum minus midline. Maximum minus midline. Edgar. You sure? Abel?
So for max minus midline, can it also be minimum minus midline? Since
So-
they're both the same?
Yeah, so we would say midline minus minimum so that we can make it be a positive number. Does that work, Abel?
Yeah.
But yes, absolutely right. Very good. Midline minus minimum. Either of these formulas work. Most times, I will use this one because the maximum is usually a positive number. I prefer to do it with positive numbers. But you can use either. It's fine. All right. Questions?